of these with you guys so you could see them. So these fall under the category of what we call complex numbers. And complex numbers come in this format. They call it A plus BI. Now, within that expression, what we would call the real part, which you guys are used to seeing, a real number, would be where they have the A. And the imaginary part is where they have B times I. I is an imaginary part there. And just to show you real quick, this is an example. If that B value is 0, which is, these are numbers you guys are used to working with. The technical format to write it as a complex number, I could write it as 4 plus 0i. 0 times anything is 0, so this would really simplify to just be the number 4. So you can really write any number you guys can think of, any real number. You could write it in this format by just putting plus 0i, and it would simplify to that number that you've already seen. What you guys are not going to be used to is the imaginary numbers. This is a purely what they call purely imaginary number. If the real part is 0, and you'll see this on some of these questions today, this would be 0 for my real part plus, I just did a little example, 3i. That could be simplified to just 3i, so the only term there that has anything left has an I attached to it, so that's an imaginary. All right, so the real number would go like here. The purely imaginary number would go like in this little box in this kind of weird makeshift diagram that they've got. Complex numbers are real numbers, imaginary numbers, and then the combination of the two. So if I have a number that has a real part and imaginary part, just as an example, maybe I have something like 5 plus 2i. Some of the questions you'll see will have answers like that today. So it has a real part and an imaginary part, so that's called a complex number. Okay, now what is this I thing? I wrote this to the side to kind of give you an example with a number. So I just wrote 5 squared is 25, right? And 5 is the square root of 25. Those are related. This is why I was developed, which is right underneath here. So the definition of I squared is equal to -1. And I know that's kind of weird because you would think two things multiplied together can't give you a negative number because, or two of the same thing. Like if I have two positive numbers, that makes a positive, two negative numbers, that makes a negative. So they literally created this. So I squared is equal to -1, and I, by definition, is the square root of -1. This will allow you to take square roots if you have a negative underneath, and it's literally just going to have an I in the answer. Okay, so this is definition of I. I squared is actually a real number equal to -1. This is mostly what we're going to work with today, is the square root of -1. Okay, so here's how I want you to think about this. We're just going to break down some radicals like we did yesterday. All right, does anybody know square root of 121? 11, right? Okay, it's a perfect square. Well, this guy's a perfect square in imaginary land. It just has a little negative in front of this. You absolutely don't have to write this, but I just want to show this to you real quick. I could rewrite this really quick as -1 times 121, right? That'd be the same thing. Now, remember I just told you, I, by definition, is the square root of -1. So this would just come out as an I, this would come out as an 11, and so you don't have to write all this work. I'm just trying to show you where this comes from because this is the first time we're looking at imaginary numbers here, but that would just be 11i. And I want to make this point to you guys, all right? No plus or minus, I'm not putting a plus or minus in front of any of these. Does anybody know why? I can be negative. I can be negative. Yeah, you could have, like I could have a -11 in front of this. Does anybody know why I don't put the plus and minus in there? Okay. Did I introduce the square root into the problem? No. If the square root already exists in the problem, these all have a radical. I did not introduce that trying to solve a problem. If that already exists, you just go with, if it's just this, all of these are just positive number in front of them, so you just go with the positive. Do not put a plus and minus. These are all just going to be a positive number with probably an I attached to it may be a radical, but don't introduce a plus and minus unless you put a square root in the problem. If the square root already exists, you don't put that symbol. Okay, now for this guy right here, right next to it, 29 is the prime number, right? There's no way I could break down or do a factor tree. There's no perfect squares that go into this. So it's not considered simplified if you have the little negative under the square root. So literally all I'm going to do here to simplify this question, to get rid of the negative, and you don't have to rewrite this, but again, to get rid of the negative, I'm just going to take an I, and if I can simplify anything else out in front like we did on the last question, we would. We can't for this problem, so this would just simplify to be I times the square root of 29. And that's considered simplified because I took the I out to get rid of the negative. That's all you have to do. Okay, now 100 is a perfect square, so negative 100 is a perfect square in imaginary land. Does anybody know what the square root of negative 100 would simplify to be, Brady? 10i. All right, so don't, again, it's not a negative or anything like this. This would just become 10i. I had this 3 out in front already, and you can just multiply these numbers together. You can always multiply. They don't have to be like terms. That's true for anything. So just do literally 3 times 10. This would simplify to be 30i. It really acts just kind of like a variable when you're looking at it. All right, now the next couple are going to be a little trickier because they're not perfect squares, but they can be broken down under a square root. All right, so anybody know biggest perfect square that would go into 8? 4. All right, so what I usually, and you don't have to do it this way, this is what I usually do. I usually attach the negative to the perfect square, so I'm just going to rewrite 8 as negative 4 times 2. What would be the square root of negative 4? Carter, we think? 2i, all right? And then you just leave the 2 under the square root, that's it. Now don't get tripped up. Sometimes, I don't know why, but people will see the negative and they'll want to write negative 2i. Don't do that. Just the square root of negative 4 would just be 2i. Let me think about this for a second. Anybody know biggest perfect square that would go into 108? I think it's 30. It's 36 for sure. Okay, so I'm just going to rewrite this real quick. Or you can use a factor tree here. You're just going to make sure you take an I out with your answer. That's all you have to do. But this is 36 times 3. Okay, so 36, negative 36, would be a perfect square in imaginary land. So what would the square root of negative 36 be? 6i. So all you're going to do, 6i comes out in front, the 3 stays underneath. The whole goal there is simplify the radical. You don't want a negative left under that square root. All right, and I got one more here. This has a 5 in front of it, so we'll have to multiply anything we take out by 5. What is the biggest perfect square that would divide into 54? What do you think? 9, yeah. I know, it seems like it should be a bigger number, but it's not. So 9 times 6 is 54, so I'm just going to rewrite that negative 54 as negative 9 times 6. Now, what am I going to pull out of this radical from the negative 9? 3i. And again, it doesn't matter if, like, 5 is a real number, 3i is an imaginary number. You can multiply them together completely fine. So 5 times 3i would just be 15i. And then the 6 would stay underneath the radical. We've taken the negative out and we've simplified that as far as we can go. Is anybody having a question so far? It works just like simplifying a normal radical. You're just going to take an I out to get rid of the negative. Okay, now, little example here. What are we doing? We're going to add or subtract these. Okay, I promise this is not terrible. This is literally just combining like terms. All right, so I'm just adding these two together. So you're going to add the real parts together. So I've got a 3 here and a 4 here. So just 3 and 4, 7, done. And then I'm going to take the imaginary parts. I have 6i and a negative 8i. So just literally like, it'd be like 6x minus 8x, just with an I instead of an x. So 6 minus 8, this would be minus 2i. And I can't go any farther than that. You can always multiply, but you can't add or subtract unless you have like terms. You can't put a real number and an imaginary number and simplify that any farther. So that would just be my answer. Now, if you are subtracting, I'm just going to give you a little tiny piece of advice. So I'm just going to drop the parentheses on that first complex number. I have 9 plus 10i. We can't simplify that any farther, so just leave that. But there's nothing in front of it, so I'm just going to drop the parentheses. If you are subtracting, you have to subtract both the imaginary part and the real part. So just think about that as kind of distributing like a little -1. So this would be -5 and -7i. And then just combine your like terms. So what would you write for your real numbers on this problem? What do you think? Mm-hmm. Perfect. 4 plus 3i, done. That's it. Does anybody have any question? Okay, I'm going to add and subtract these two questions underneath here, but I got to do one step first because they didn't write it as a complex number. They wrote it as like 2 or whatever plus something under a square root. So 2 plus the square root of -16 would really be what? 4i. So this is 2 plus 4i. And again, notice I kept the sign exactly the same. Like don't change, I don't know why, but sometimes people will just automatically change that to a negative. So this says 2 plus, so keep that a plus. All right. And if I have 8 minus the square root of -25, what would that really be? 5i, yeah, okay, so 8 minus 5i. Okay, now this one's just adding, so you could literally just drop the parentheses. We're just going to combine like terms. So I got 2 and 8, so I'd have 10. And then 4 minus 5 would be just minus 1i. You're probably not going to see a 1 written in front of it. It would probably just be written as 10 minus I. All right, and then the last one. This is kind of tricky. What is this first term is really 6 minus what? Just I. That's literally the definition. I is the square root of -1. So that's literally just 6 minus I. All right, now I'm going to subtract from that 11 plus what? 8i. Good deal. And then just if you do have a subtraction problem, just think about it for me for 1 second. You do have to distribute the subtraction symbol to both the real part and imaginary part. On this first term, I could just go ahead and drop the parentheses. There's nothing in front for me to distribute, but I got to put a -1 through both of these terms right after it to subtract it. So it would be minus 11 and then minus 8i. Can anybody just raise your hand, try that one? What would your final answer be? What do you think? Right, good deal. Minus 5 minus 9i. Is anybody having a question? Just kind of running through some different operations with you guys with these imaginary numbers. Okay, now, this is going to work just like multiplying. You can always multiply. You're using your properties of exponents here, but I have to remind you of something very quickly. As part of the definition, if you end up with an I squared, that is actually a real number. That is equal to -1 by definition. So it's possible when we do some of the multiplication here, you might get an I squared, so you might be able to simplify it and actually get a real answer. And that's what's going to happen on this very first question. If I take 3i times 8i, just think about that like 3x times 8x. You would take the 3 and 8, you're going to multiply those guys together, you get 24. I times I becomes I squared. Now, really, if you remember, I just wrote this down, I squared by definition is actually equal to -1. So this is going to become a real number. This is really 24 times -1. And so then my answer to the question would be -24. No imaginary part left. If you square something, this is -5i squared. This means -5i times itself, so -5i times -5i. Just do -5 times -5, right? Positive 25. I times I becomes I squared, and almost identical to what we just did. This is 25 times -1, because I squared is equal to -1. So I don't know why I just wrote 24, sorry. -25. That's it. And then I have one more. We're just going to do a little distributive property here. So I'm going to multiply. You can always multiply. They don't have to be like terms to multiply. They do to add or subtract, but not to multiply. You can always multiply. So I times 11 would just literally become 11I. This next term, though, it would be I times negative 10I, so it'd be negative 10I squared. Now, the 11I, I'm just going to leave that alone. This is really negative 10 times negative 1, that second term, because I have negative 10 times I squared being the negative 1. So this is really 11I plus 10, and I'm not really going to be nitpicky about this, but I am for 1 second. If you have, and kind of the way I laid that out, it's supposed to have the real part come first and the imaginary part come second if you have both parts. So the way I should write my answer for this last question, sorry, there's not a lot of space, I should write it as 10 plus 11I. The real part is supposed to come first, the imaginary part is supposed to come second. Is anybody having a question? Yeah, I'm gonna have you guys do like a little foil with this. And then I'm gonna have you graph an imaginary number, which is super cool, only to me. All right, now, all we're gonna do here, this just works just like a normal foil. Or if you wanna draw yourself a box, you can draw yourself a little 2x2 box, works the same way. So we're just gonna do, I think of it as like a double distributive property. So if I do this one here, I'm just gonna do 3 times 2, so I'm gonna get 6. 3 times 4i, just gonna multiply the numbers together. So that would just become 12i, totally legal to multiply that. Negative 7i times 2 would be negative 14i. All right, now the last term, negative 7 times 4 is negative 28, and then you end up doing I times I, which is I squared. Now, I'm just going to simplify this just a little bit. The 12i and the negative 14i, those are like terms. I'm just going to combine those real quick. So 12 minus 14, we'd have negative 2i. And this term on the end is really negative 28 times I squared, so it'd be negative 28 times negative 1. So what is that term on the end really, if I would simplify that? Positive 28, exactly. So plus 28. Now, I can combine the real numbers there. So 6 and 28 added together would give you 34, and then minus 2i. And then I've got it in that proper format, that a plus bi. A is the real part, bi is the imaginary part. You guys try this next one. I'm just going to do it up here without talking. You guys try this next one. See if you can foil this out. Remember, I squared is going to become negative 1. And see if we can combine the real parts. So look good. Is anybody having a question about the foil? Okay, you should get negative 59 plus 21i. Okay, awesome. Now, here is absolute value of a complex number. Okay, what is being graphed over here is the complex number 3 minus 2i. All right, that's what's on the graph here. So I'm just going to kind of explain this to you. All right, this looks like an x and y axis. All right, the difference is what they do. Where you guys are used to being the y-axis, this is the imaginary axis. So basically the y-coordinate would be, if I was thinking about this, let me draw this real quick, and then I'll show you how to think of it as the point. What you guys are used to seeing as the x-axis is what they call the real axis. So if basically, to show the absolute value here, we're going to show a distance. But this would be graphed as the point 3, -2 is what it would look like if you were going to plot this just in a normal XY coordinate plane. But it's the real axis and the imaginary axis. So what you got going on here, I'm going over 3, and then I'm going down 2i, and I end up at this point right here. So that is the point. Now, if you are asked for the absolute value, so you'll see a question, this one actually gives it to you. I just want to show you where they got it from. So the absolute value is the length of that segment that connects the origin to that point. So how would I find think back for geometry real quick for me. How would you find the length of the hypotenuse of that triangle? Yes, this is literally just a little Pythagorean theorem. So basically what I have here, if you guys think about your Pythagorean theorem, you got your a squared plus b squared equals c squared. And you can follow the little formula that's there. I would just tell you, just think about the Pythagorean theorem. This is 3, this is 2, and where you're used to seeing c, that distance from the origin to that point in the complex plane, that is the absolute value of that lovely complex number. So all we got to do is a little tiny Pythagorean theorem. So I would just do like 3 squared plus 2 squared equals that length we're trying to find. Just that distance is the absolute value for that point. This ends up being 9. This ends up being 4. And add that together, you get 13. And we would have to take a square root. So that's where they're getting that in the problem right underneath the graph, that distance is the square root of 13. It'll be a real number. Absolute value is just the distance from the origin to wherever that point is in the imaginary plane, or complex plane, I should say. Okay, so we're just going to practice graphing these. And it's not labeled or anything, I'm just going to sketch it. What would the real part be if I just give you -7i? Like, I'm going to try to graph a point here. So what would the real part be? 0. All right, so this is really 0 minus 7i, the same thing. So if you wanted to think about this like a point, this would be the point 0, -7. Where you guys are used to seeing the x-axis, that's the real part. The imaginary part is where you have the I. So if I were going to graph this just real quick, and I don't have this marked at all, but let me just come down here. Let's say this was -7. This would not go left or right. The point would be like right there. I'm just eyeballing something there. What would be the distance? Like, do I need to do the Pythagorean theorem there, or could you just tell me that distance from the origin to that point? Do what? We don't even have, like, what would the like, if this is -7, what's the distance from the origin to that point? It's just 7. You don't have to do any Pythagorean theorem here. This distance is always positive. This literally would be the absolute value here. This would just be 7. You don't have to do a Pythagorean theorem. Okay, now, if you do have two parts to it, like this has a real part and imaginary part, I'm just going to eyeball something. I'm sure this is not accurate. Let's say this is 10, and so this would be the point 10, 24 on the graph. All right, so I'm just going to say, like, okay, this is 10, and maybe up here is 24. So the point would be somewhere like up here. And I'm going to try to find that distance from the origin to that point. So and there's a couple ways you could do this, but I'm just going to make a tiny little right triangle. So I'm going to go over 10, right, and up 24. That would make a right angle right there, so I could just use my little Pythagorean theorem. So this would be 10, this would be 24. This one is actually a nice number. Maybe I'll call that C just so it matches the Pythagorean theorem. But I'm trying to find that distance from the origin to that point to give the absolute value of that imaginary number. So we're just going to do 10 squared plus 24 squared. That would equal, I just labeled it C so it would look like the Pythagorean theorem. Okay, this ends up being, let's see, 24 squared is 576, so this is 676. And I don't know if you guys know this, but that's actually a perfect square. 676, if you take the square root of that, I'm pretty sure is 20, yep, it's 26. So this ends up being a nice number. That would be your absolute value of that complex number there. And then I just have one more just for us to try. The real part's -6, the imaginary part is -4i. So this would be like graphing the point -6, -4 in the complex plane. So the real part is like your x-axis, the imaginary part is your y-axis. So I don't know, I'm just going to eyeball. Like let's say this is -6, and I'm just eyeballing this. Let's say this is -4. So the point would be kind of somewhere here. And there's a couple ways you can draw this, but you're really just trying to make yourself like a little right triangle. And when you have the triangle, you're just going to go, I'm going to go straight to the left and straight down. That'll make a little right triangle there. The distances for the legs should just be the coordinates of the points. So this guy would be 6, this guy would be 4. And I'll just call that C just so it matches up with the Pythagorean theorem. So I'm just going to do 4 squared plus 6 squared, and that would be the length of my segment from the origin to that complex number in the complex plane. That absolute value we'll just get by solving this. All right, so I got 16 and 36, which is going to give me 52. Is 52 divisible by any perfect squares? I think it's divisible by 4. Let me check. Yes, it is. So I can break this down just a little tiny bit. This is 4 times 13. And so my square root of 4, I could pull a 2 out in front. If you guys want to use a factor tree instead of trying to find the biggest perfect square, you could do that too. But biggest perfect square that's going to go into 52 is just going to be 4. So I could simplify that a little bit. So 2 roots of 13, that's going to be my absolute value. Is anybody having a question about finding those distances? It's really just Pythagorean theorem. It's not terrible. Okay, now the last thing we're going to do today is actually solve a couple equations. Okay, now I don't have any square roots in any of these problems. So if we end up using a square root to solve a problem here, we do have to use that plus and minus symbol. None of the other problems today, but none of these have square roots in them. So if we introduce a square root, we do have to put the plus and minus. So extremely similar to yesterday. We're going to get a negative under the square root though. I'm just going to get x squared by itself. And the only difference is we're going to get a negative number under the square root. So here I am introducing the square root to get x by itself. The square root was not already in the problem. So if we introduce the square root, that's when you got to put the plus and minus symbol. This does actually have 2 answers. What would the square root of -25 be? 5i. So I'm just going to put plus or minus 5i. And you guys can check that. If you plug that back in, 5i times 5i, right, would be 5 times 5, so it would be 25. And then I squared would be -1. So this would be -25. If I do -5i times -5i, that would be +25 times I squared again, which would give you -25. So both of those answers work. You would not see this on a graph. Like if we graphed a parabola like that was x squared plus 25, it wouldn't touch the x-axis, but it does have 2 answers. They're just both imaginary. All right, so for this guy, just get the x squared by itself before you try to take a square root. Let's see, 98 divided by 2 is 48, right? But oops, sorry, it's negative. I'm introducing the square root into the problem. Unfortunately, this guy's not a perfect square, so I got to break that radical down a little bit. Anybody know the biggest perfect square that goes into 48? 16. Okay, so 16 times 3. And again, this is just my thing, but I just attach the negative to the perfect square so I don't forget to take out the I. So, and I almost forgot my plus and minus. So out in front here, we're going to pull a 4i to take care of the negative, and then the 3 stays under the square root. So those 2 solutions would be my answer. And again, if you want, you could plug this back in for x. It would be a little bit of work because you've got a radical there, but you could solve that and plug it back in for x to check. All right, now the last one. Please, please, please. Don't forget this. Don't foil on this last question here. If you see parentheses like that and you have an equation, you want that, because if you can get those parentheses alone, you can just take a square root and dispose of that whole thing. So don't FOIL that out. I'm going to divide by 3 real quick. I didn't leave enough space, did I? All right, so I'm going to divide by 3. We want these parentheses alone because I can just take a square root to get rid of that whole mess. What we're going to end up with under our square root is this negative 20. All right, on that left side, square root and squared cancel each other out. So I'm just going to go ahead and drop the parentheses so we'd have x minus 5. Anybody know biggest perfect square that goes into 20? 4. So I'm just going to rewrite this real quick as negative 4 times 5. If you can simplify that quicker in less steps, that's totally fine with me. I'm just trying to show you where it comes from. So this side here would simplify to be 2i times the square root of 5. Now, not my answer though, because on the other side I had that x minus 5. Now, we don't really have to do much else. I got to move that 5 to the other side. And if you guys remember me telling you this yesterday, I just tell people just write it right after the equal sign. All right, so x equals, I'm going to write 5 plus or minus 2i radical 5. Can I do anything else with that? Can I add 5 to the 2i radical 5? No, they're not like terms. So you just leave your answer right like this. Just, it's 2 separate terms. I can't add that real part to that imaginary part because it's got a radical as well. So we can't do anything else there. Is anybody having a question? Okay, I feel like I'm talking.